Hello all. Today's video is kind of spontaneous. I've seen these tier list videos all over YouTube, trying to rank anything from movies, physics equations, universities, jobs. What else have I seen? Actors, Nobel laureates, etc. So as you know, I try to think of different kind of videos I can make in my channel, and I felt that it is appropriate to do a ranking of A-level physics equations, okay? Since most of the viewers of the channel are A-level physics students, we're gonna do this. So it's gonna be totally biased and fun. But okay, I'm gonna take into account things like the significance of an equation, how difficult it was to be derived or discovered, the significance it has in physics, how fundamental it is, and stuff like that. So, but this is gonna be totally fun. And the reason why I'm doing this is because I don't know, I felt jealous of people doing this kind of videos, so I just wanted to make one for myself and you guys, of course. And also lately I've been working non-stop on making physics notes and trying to think of different kind of videos I can show, etc. So my brain is filled of physics and math, and I mean, sure, I taught physics for many years, etc., but still it takes some effort to think about how to present the material and so on. So this is just gonna be a break for me, something like that. So anyway, let's dive in. So here's the tier list. We will have the S, like the supreme, I guess, like the best of the best equations. And then we have A, B, C, and D. And we'll start with a formula that gives you the period of the oscillation of a simple pendulum. And I'm inclined to put it in D. The reason is that it's not a fundamental quantity. Once you have Newton's laws of motion, you can figure it out quite easily. So I'm gonna put that in D, and I'm gonna do the same with the formula that gives you the velocity in simple harmonic motion. Maybe I can put it in C, given that, okay, it's a little bit difficult for students, so let's put it up there, okay? Next comes the gravitational force experienced between two objects that have some mass. And I'm inclined to put it in B. It's very significant for physics. Whenever I know the history, I'm gonna say it because I'm doing this on the fly. I haven't scripted this video. I'm doing it with whatever I have in my head right now. So, but the history of this is that Kepler came before Newton, and he came up with Kepler's laws of motion, as they are called. And Newton sort of, I mean, after Kepler, like I don't remember if they lived around the same era. I think they did not. But anyway, Newton tried to come up with a way to describe with an equation that would from which Kepler's laws could be derived, and he came up with this. And we're talking about an equation that is at least when did Newton live? Maybe 300 years ago or something. So yeah, I'm gonna put it in tier B. Next comes Newton's second law, and which is also, okay, they have F equals ma and also mv squared over r, which is the centripetal acceleration. V squared over r is the centripetal acceleration. Arguably, it's the most important law of physics, so maybe I'm gonna put it in tier A, okay? It was one of the first laws to be discovered, I guess. Let's see. Maybe, no, shall we Google it? No, yeah, okay, so Newton's laws. Okay, let's see. Newton's laws of motion. Okay, this is a Wikipedia page. Okay, Newton, when did he live? Okay, he died, yeah, 300 years ago. So yeah, I was right. I wanted to check the date. All right, let's move on. This is one of the Suvad equations, the next one. Students find it hard to use, so I'm gonna put in tier C, even though it's easy to derive because it's a consequence of Newton's laws of motion, pretty much. I mean, of Newton's equations. So it's not a fundamental equation. And when I say fundamental, I mean equations that describe one of the four fundamental forces of the universe, which are the laws of gravity is a fundamental equation. I mean, this equation over here is fundamental, but this one is not, because this one is derived from this one once you have the force. And the force in simple harmonic motion is kx. I hope I make sense, by the way, because I'm talking to high school students. So if I make no sense, just comment. I always respond to the comments. I am living for the day in which there will be thousands of comments, and I won't be able to reply just because the comments are so many. Okay, but I feel like that's gonna take a long time. So for the time being, I respond to all comments because maybe I receive at most 3 or 4 comments per video. So it's a little bit sad, but okay. All right, next one. This is a Doppler effect for light. The Doppler factor z, which is equal to the velocity of a star as it recedes over the speed of light, and it gives you the red shift or blue shift and so on. Is it fundamental? No. Is it important? It is. Do students find it hard? They don't. I dare say that you guys find these problems easy, okay? So I'm gonna put it tier D, okay? I'm sorry, but I'm sorry, I am apologizing to Doppler, I guess, but okay, I'm gonna put it tier D. Okay, gravitational potential energy. Okay, I'm gonna put it tier C. No explanation, okay? Let's move on. I'm gonna put this tier D. This is the power, which is energy per time. Okay, Snell's law. Okay, it was discovered a long time ago. It's optics. I know optics. I understand it. I wish I knew more about stuff like non-linear optics and weird materials and such, but I don't. I'm gonna put it tier D just because I don't find optics fascinating. By the way, what happens if I was wondering what happens when you start filling these categories, but I guess they just keep expanding. This is a website. I'm gonna give the link to. It's tiermaker.com. It's a website that allows you to do these things. So, okay, I grabbed the law of nuclear decay. I put it in tier D, and I'm a nuclear physicist, but it doesn't really describe anything fascinating. It doesn't really have the wow factor. So I'm gonna put it there. Okay, no further explanation needed. Let's move on. I'm gonna do the same with lambda, which describes the decay constant as a function of the half-life. Then we have the formula for the period, also tier D. Okay, the intensity of radiation received from some light source of luminosity L at a distance D. Let's put this tier D as well. Students find these kind of problems are easy for students. Okay, the energy stored in a capacitor, also tier D. Nothing fascinating or fundamental there, I don't know. Okay, now we have the luminosity of an object, usually stars. This is Stefan Boltzmann law. Let's put it tier D. It's kind of fascinating. You can figure out the luminosity of a star, and then you you can figure out things about distant stellar objects. So it does have the wow factor. So I'm going to put it there. Okay, PV equals NKT, the ideal gas law. Also tiered C, okay? Students do not find this kind of problems easy. Is this a fundamental equation? Kind of is. It was discovered. When was the, okay, ideal gas law? Let's see, I actually don't know. Ideal gas law, it should be during the first industrial revolution era, because the first industrial revolution has to do with thermodynamics and engines, Carnot cycles, for those of you who are deep into physics and so on. But I would say 200, maybe 300 years ago. Do they say? Okay, 200 years ago. Okay, it was first stated by Clapeyron. Okay, Benoit Paul. Okay, this is a French name. Yes, Benoit Paul Émile Clapeyron, I guess. It's a combination of the empirical Boyle's law, Charles' law, and Avogadro's law, and Guy Lussac. Okay, all right. So 200 years ago. Okay, let's put tier C though. By the way, at some point we have to put something in tier S. We'll get there. Okay, the resultant force equals mass times acceleration. This is Newton's second law. Let's put it tier A. Okay, it's an important law of nature. V equals omega r for circular motion, tier D. Okay, the law, how is this called? It has to do with lenses. This is the focal length. U and V is the distance of the object and the image from the lens. Let's put tier C. Okay, it's optics and so on. Okay, electric field force per charge. Tier D. Okay, the gravitational potential is given by minus gm over r. Let's put it tier D. Same for the period for, the period for a spring should be in the same tier as the period for a pendulum. Okay, the radius of a charged particle in a magnetic field. Okay, let's, it's a fascinating thing. It was discovered by Lorentz, I think, about 100 years ago in California. Let's put it tier C. Okay, the force on a current carrying wire of some length L or rod or something like that. Let's put it here B. D. All right, Suvat equations. Okay, we will put them in tier C because we put other Suvat equations in tier C earlier. Power equals voltage times current. Tier D. The velocity of a string under some tension T, and I guess mu is the mass per unit length. Let's put it here D. Density equals mass per volume, tier D. The elastic energy stored in a spring, I guess, or any elastic material, we can put it in tier C. All right. Okay, the definition of a current, charge per time, D. The energy stored in a capacitor again. Where was the other one? Tier D, okay. The ideal gas law, but as a function of the average squared velocity of molecules and the mass of the molecules and the number of molecules, should be in the same tier as the ideal gas law, so C. Power is V squared over R, power consumed, that, if you have a resistor, the power consumed, I guess, by the resistor is V squared over R, tier D. Okay, will I find anything to put in tier S? We'll see. The definition of momentum, tier D. The RMS voltage, tier D. The impulse, F times delta T. Let's put it tier C. Coulomb's law. Okay, this one goes tier B, just like the gravitational force. Okay. The photoelectric effect. There you go. This is tier S. Okay. And the reason for this, I mean, it's not something that students find hard to understand, but it's significant in the history of physics. I mean, this equation gave Einstein his Nobel Prize. I mean, most people think that he got it for the relativity, but no, he got it for the photoelectric effect. It was also verification that light behaves as a particle as well as a wave. Okay, so it's very important in the history of physics. So let's put it here, S. Okay, kinetic energy. Okay, let's put it here, C. Okay, in both forms, 1/2 mv squared and p squared over 2m. The diffraction grading, tier C. The force on a spring, okay, or any elastic material. I guess we can put it tier D. Okay. Okay, the velocity of a stellar object is a function of the distance. Okay, and that's Hubble's constant. I'm gonna put it tier B. Okay. So we're here. Let me drag it up there. Okay. All right. Okay. The critical angle, tier D. Again, power and stuff like that. I'm gonna put it. Sorry, it's the work done, I guess, by voltage. Okay. Okay. Sigma A t to the fourth. I'm gonna put in the same category as C. I mean, they are the same equation, right? So. Okay, Young's modulus, tier D. Force on a charged particle, tier D as well. Excuse me. Okay, this is another of the Suvat equations. Would you put in tier C earlier? So let's keep doing that. Too many equations, oh my God. Okay, power consumed by a resistor, let's put it tier D. The equation for discharging of the discharging of a capacitor, okay, let's put it tier D. Capacitance definition of the resistance of a resistor as a function of the material that makes up the resistor times the length over surface area, the cross-sectional area. Okay, the kinetic theory of gases. So 1/2 m times the squared velocity of a molecule is 3/2 kT. This should go in the same tier as the ideal gas law. Okay, Ohm's law, nothing fascinating there. Delta E equals L delta M. The latent heat, let's put it here, C. Okay. The activity of a source, lambda n, tier D. The electric field between two parallel plates, tier D. Moment of a force, nothing fascinating, tier D. Okay. Faraday's law, okay, that's a fascinating law actually. I'm gonna put it tier C, okay? All right. Simple harmonic motion, acceleration. Where did we put the rest of these equations? Is it tier D or let's see, tier C. Okay, let's do tier C. I'm gonna drag it over here and then drag it up there. I need a bigger screen for this. Okay. Efficiency equals useful energy output, total energy input, tier D. Wien's law, tier D. And the speed of a wave is a function of its frequency and its wavelength, tier D. P over A, let's put it tier D. Cm times delta theta, the change, I mean the energy needed to heat up materials, let's put it tier D. Current, tier D. M times G, the weight, tier D. Oh my God. This is, come on, Stokes law, right? Yeah. This is the first equation I don't remember. Stokes law, force, something like that. Yeah. Okay. I do remember it. Okay. Just because of that, it deserves tier B, I guess. Okay, let's do tier B. Okay. The magnification, tier D. Okay, the energy of a photon, let's put it tier A. Okay, it was important historically. It's an important equation. I'm pretty sure everybody will disagree with my ranking, but okay, let's put tier A. Again, simple harmonic motion, I think we put it in tier C, so it's the displacement now. Okay, tier C. All right, de Broglie's equation. Okay, it's very simple to use, but it was a very important discovery. So actually this, for me at least, goes to tier S. Okay, you didn't expect that, did you? So, okay. It's the power of a lens, right? It's 1 over the focal length, yeah. Tier D, okay. The energy stored in a capacitor. We had equations like this ranked in D before. And then we have the OG of physics equations, okay? Einstein's formula that relates mass and energy. And this obviously goes to tier, come on, is it tier D? No, it deserves better. Is it tier C? No, it deserves better. Is it tier A? No, it's tier S, guys, okay? And I guess I'm a little bit biased, but 2 out of the 3 equations we put in tier S are related to our friend, Mr., I guess, Professor Albert Einstein, okay? And then H over P is de Broglie. Okay, we have many of Newton's equations in tiers A and B, I guess. But most of the equations go in tier S and tier D. And this is the video. I don't know if this is kind of interesting, but I don't know. We'll see. By the way, can I save this? Save or download? Yes, I can. Okay. Let's do download image. Okay. So, okay. Okay, this was the video, guys. I hope you enjoyed. Let me know what you think in the comments. And I don't know. I needed a break, guys. So I'm sorry. It will take a few days before I upload.